Hey guys, welcome to another video. So in the continuation of the previous video where we have discussed the problem of the day search pattern using a naive approach or a brute force approach, we are here with the optimized approach where we will use KMP algorithm. So let's discuss what is KMP algorithm. So the whole KMP algorithm is based on longest preferred prefix which is equals to the suffix. To understand that, let's take another example. Let's say our given pattern string is ABCAB. Here we can see we got AB as a prefix which is equals to the suffix AB. Thus according to this we will create an array where we will store the values of longest prefix suffix. So when there is no match between two characters within the pattern string itself, we will simply add 0 in our array, and if we found a match then we will update our array index with the length of the prefix suffix. So we will create an array of the length of the given pattern string. In our case, AB is length of 5. So we will create an array length of 5. So we will start iterating from the first character of our pattern string. And for the first character, we can say there is no suffix of a single element or the single character. So we will simply put 0 at the first index of our array. Now we will start our iteration from this index and we will check if this character is equals to the previous character or not. That is, the prefix is equals to suffix or not. If it is not, then we will simply add 0 to our current index in the array. And this process will be followed until we found a match with our prefix. C is not equals to A, so we will add 0. In the next iteration, we can see there is a match. That is, A is equals to A. Thus, we will update our current index value in our array by the length of the similar characters in our pattern string. So, it is of length 1. Thus, we found equal prefix suffix of length 1. In this case, when we found a match, we will increase our pointer to this character. Now, every character will be matched or compared with B. So we are left with the last character of the pattern string, that is B, and we found a match again. Thus we will update the value of array index by the total length of equal prefix and suffix. So we got AB in our prefix and AB in our suffix. So the total length is 2. So we will add 2 in our array. And thus we are ready with our LPS array. So by now we got to know how to create an LPS array for our pattern string. So let's quickly make our LPS array for the given example in our problem, that is for geek. So the LPS array for geek will be, we will create an array of length 4, and for the first character it will always be 0. Then we will iterate further. E is not equals to G, we will add 0 in our array. Again, rest of the characters is not equals to G, so we will simply add 0 in every indexes of our array. Thus we have created our LPS array for a given pattern string geek. Now we will continue with our KMP algorithm. And now according to the algorithm, we will keep on iterating in our text string and compare every character with our pattern string until we reach to the end of a pattern string, or we get a mismatch in our pattern string and text string. So let's give a quick dry run. Here G is equals to G. We will increase our pointer in both the strings. Again we can see there is a match. E is equals to E, and accordingly all the characters we can see are equal till the end of the pattern string. And at last we will check the pointer which was used while iterating in the pattern string is equals to the length of the pattern string or not. If it is equals, that means each character in our pattern string is equals to each character in our given text string. And in that case, we will simply add our I minus j plus 1th index in our array list, in our result array list. Why we added 1? Because we have to return one in 1 based indexing. After adding the index in our array list, we will simply iterate further in our text string, but we will update the pointer in a pattern string based on this LPS array. So we will update the jth index by LPS of j minus 1. In our case, or in our example, j was here, which is 3. So 3 minus 1 is 2. And in the second index of our LPS array, we got 0. So our j will start iterating from the 0th index of the pattern string. Again, we will compare the characters between the pattern string and the text string. In the current iteration, S will be compared with G, which is not equals, and thus we will increase our pointer and our J will remain at 0 for every mismatch cases. And at the ninth iteration, we can see G is equals to the first character of our pattern string. So in that case, we will update our pointer in both of the string. So it will point to E and this will also point to E. Both are equal. We will again update our pointers. Again, both are equals. So we will keep on updating till we found a mismatch or till we came to the end of our pattern string. In our case, we came to the end of our pattern string and thus we will check whether the j is equals to the length of the pattern string or not. And if it is equal, we will simply update our result array list by I minus j plus 1 and will increase our ith index and will update our jth index by LPS of j minus 1. So again, LPS of j minus 1 is 2, that is, it will be pointing to 0. So our pointer will point to the first character or the 0th character in our pattern string. So at last, S will be compared with G, which is not equal. In the next iteration, I will be equals to N and we will end our loop here. Thus, we have got our resultant array list and we will return this array list. So this is all about the KMP algorithm. Now let's get into the code quickly. So let's create our result array list. Let's name it as indexes equals to new array list. Let's store the length of our pattern in text string. Now we have to create an LPS array for our given pattern string. So let's name it as LPS equals to, and we can call a function where we will compute the LPS array. So let's name it as compute LPS array and pass our pattern string. And when we got our LPS array, we will start our iteration till our pointer in the text string is less than n. So let's initiate our pointers. So int I is equals to 0 and j is also equals to 0. So I is the index for the text and j will be the index which will handling the pattern string. And while iterating, we will check if the character at pattern string is equals to the character of our text string. So according to our discussion, if both the character is equal, we will simply iterate further. So we'll increase our I and j. And in the process, if we find j is equals to m, that means every character in our pattern string is found in our text string. In that case, we will simply add up our index in our result array. We will add I minus j plus 1. And for the next iteration, we will update our jth value with LPS of j minus 1. So by updating this value of j, when we found a match, we are ensuring that we are not checking the pattern again, which we have found earlier. Thus, it will optimize our code. And after that, we will check for the condition where both the characters are not equal. That is, pat.caret j is not equals to text.caret I. And also, we can ensure that our I is less than n. So in this case, when both of the characters are not equal to each other, we were simply updating our jth index if it was not at 0th position. If the j was pointing at the 0th character of a pattern string, then we were not updating it. But in case j is not equals to 0, we were updating it with the value present at LPS of j minus 1. So let us quickly write the code for that. If j is not equals to 0, that means it is not pointing to the first character of a pattern string. We will update our j with LPS of j minus 1. And if the j is already pointing to the 0th character of a pattern string, we will simply update our ith index in our text string. Thus, this process will follow for each character in our text string, and after that, we will return our result array list, that is indexes. So we are done with our main logic. Now let's quickly define our compute LPS array method. Let's store the length of the pattern string in a variable m, where m is equals to pat.length. Let's create our result array, that is int LPS is equals to new int, and the length of the array will be equals to the length of the pattern string. We have discussed this in the first part of the video. Now we have to take a variable which will store the length of the previous longest prefix. So we will take length is equals to 0. This will store the length of the previously found pattern in our pattern string itself. So if you remember the example where we took pattern string as ABCAB, the length of the prefix was 2 and the suffix was 2 and both the pattern matches to each other. Hence we have updated our array index by the length value. of that prefix and suffix. Now we will start our iteration from the first character of our pattern string, because there is no need to check the suffix of the 0th character or a single character. There is no suffix for a single character. That's why we were starting from the first character of a pattern string, and it will iterate till the length of the pattern string, and we will increase our iteration based on some conditions. So our first condition is, if the first character of a pattern string is equals to the previous character of a pattern string, which can be computed by pat.caret length. If this condition is true, that means we found a match. There is a similar elements or similar characters in our pattern string. So we will increase our length and will update our LPS array of ith index by the value of length. And as we have found a match, we will increase our pointer by 1. So in the else part, that means when there is no match between two characters in a pattern string itself, we have to check if the length is equals to 0 or not. If it is not equals, then the length will be updated by the value stored in LPS of length minus 1. So we have encountered a similar approach where we are updating our length value by the value of LPS of length minus 1. So simply we are doing this because when our length is not equals to 0, that means we found a similar prefix and suffix. This thing is clear, right? And if we found that similar prefix, then we should not start our iteration in a pattern string with 0th index. So to optimize our code, we will start our iteration where the previous prefix was ended. And in case there is no prefix suffix found previously, we will simply update our ith index of our LPS array with 0, and we will increase our pointer by 1. And at last, we will simply return our computer LPS array. So this was all about the code using KMP algorithm. And now let's just compile and run quickly. So there is some compilation error at line 72. So it's a typing mistake. It will be caret I. Let's compile it again. So compilation completed. Now let's just quickly submit our code. Thus, we have successfully passed all the given test cases using an optimized approach, that is using a KMP algorithm. So let me know in the comment section why every test case was passed using the previous code also, where the time complexity of that code was expected to be big of n into m. And if you have found this video helpful, please like, share and subscribe our channel, and let's get back in the next video again. Till that, happy coding.